Hey there kiddos, here is your video over quadratic formula. You use the quadratic formula to find the x-intercepts or the solutions if your equation is in standard form. It's got to be in standard form before you can use the quadratic formula. Quadratic formula is best to use whenever the quadratic that you have that you're trying to solve doesn't factor, so you can't find numbers that work so that you can draw your box and plug in your factor, or when you don't feel like factoring. Sometimes quadratic formula is a lot easier, and some people just prefer it. It just makes sense for them to be able to plug numbers in. So here's what the quadratic formula looks like. It's a big formula, and really all we're going to do is we're going to plug numbers into it and then just solve. So here's what it looks like. It's x equals the opposite of b plus or minus the square root of, and it's the plus or minus because remember you have a square root, b squared minus 4ac all over 2a. This part of the quadratic formula right here, this whole part, the square root, I don't know why it's not picking up a pen. This whole part right here, this whole entire square root has a name. It's called the discriminant. And we're going to use the discriminant in just a minute to determine how many solutions something has. And we'll talk about that. And when you do the quadratic formula, if you'll find the discriminant first, then it simplifies the problem that you have to do. And so when I do quadratic formula, I always start by finding the discriminant first, and then I go and plug that into the rest of the quadratic formula and then solve from there. But you do have a calculator. That calculator will come in handy when you're trying to do these kinds of problems. So first thing we're going to do is we're going to use this discriminant, this part under the square root, to figure out how many solutions exist. And so in order to do this, the first thing we're going to have to find out from our quadratic is what a, b, and c are. Well, here's my first quadratic. I've got 1x squared minus 4x plus 3. In this problem, a is 1, b is negative 4, and c is 3. And we're going to use that to plug into the discriminant, and that will tell me how many solutions exist. And the discriminant is just the b squared minus 4ac. It doesn't include the square root symbol. It's just what's under the square root. So I'm going to do b squared. So I have negative 4 squared minus 4. It's always 4. That's part of the formula. Times a, which is 1, times c, which is 3. And I'm just going to grab my calculator, and I'm going to type that exactly like I wrote it, parentheses and all. So I have negative 4 squared minus 4 times 1 times 3. And when I do that, I get that the answer is 4. So what I have is a positive number as my answer. And whenever you do the discriminant and you have a positive answer, it tells you that you're going to have 2 solutions. So this problem right here, if I use the quadratic formula and I solve the whole thing, I'm going to get 2 solutions. Okay, so it means that my parabola crosses the x-axis twice. So number 2 here is not in standard form. It does not equal 0. It's not in standard form. So I've got to get this minus 2x and this minus 1 to the other side. So I'm going to add 2x and add 1. So this becomes x squared plus 2x plus 1, and that equals 0. So now I can list out a is 1, b is 2, and c is 1. So I'm going to do my b squared minus 4ac part again. So b squared is 2 squared minus 4 times a, which was 1, times c, which was 1. And when I plug that into my calculator to find out what that equals, I get 0. And when you use the discriminant and you get that 0 is an answer, that is how it lets you know that you only have 1 solution. So when you solve this problem using the quadratic formula, you will only get 1 answer, which means that your parabola goes to the x-axis, touches it, and then bounces off and goes back the other direction. So it doesn't cross it, but it does touch it, and it only touches it in one place. So you have 1 solution. So this last one, the third one, again, it doesn't equal 0, so I'm going to have to subtract 2x from both sides to make that happen. So it becomes x squared minus 2x plus 2 equals 0. So again, a equals 1, b equals negative 2, and c equals 2. And then I'm going to plug that in. So b squared, I have negative 2 squared minus 4 times a is 1, and c is 2. And when I plug that into my calculator, make sure you use parentheses around the negative sign. I get that the answer to this is negative 4. Now, because when I use this, I'm going to put that negative 4 underneath a square root, and we've discussed this already, that we can't take the square root of a negative number. It's not something we know how to do. And so when this happens and your discriminant ends up being a negative number, it tells you that you are going to have no solution, because you are not going to be able to solve that problem because you cannot find the square root of a negative. What that tells me is that when I graph this, I have a parabola that sits above the x-axis or below the x-axis somewhere, and it never touches it or crosses it at all. And so this one crosses it twice, this one touches it one time, but this one never touches or crosses the x-axis. So now let's solve some problems using the quadratic formula. So I have it written down for you again, and like I told you, the first thing I do when I solve one of these problems is I find the discriminant first. Number one, it simplifies what has to be plugged into my formula. Number two, it tells me right off how many solutions am I going to have so that I don't have to worry about it. So we're going to take this 2x squared equals 7x minus 3. I've got to make it equal 0. So I'm going to subtract 7x, and I'm going to add 3. So it becomes 2x squared minus 7x plus 3 equals 0. So A is 2, B is negative 7, and C is 3. So step one, we're going to find the discriminant. So we're going to do b squared, negative 7 squared, minus 4 times a times c. I'm going to grab my calculator using parentheses around my negative, and I'm going to find out what that equals. And I get that that equals 25. Well, that's a positive number, so I know I'm going to have two solutions based on what I just did a minute ago. So to solve with the quadratic formula, I have x equals. The first thing in that formula is the opposite of b. Well, in this case, b is negative 7, so the opposite is positive 7, plus or minus the square root of 25, because this is that b squared minus 4ac right here. So I just plug in my 25, all over 2a. So I have to do 2 times 2 because a equaled 2. So now we'll simplify. We're going to grab our calculator and we're going to take care of this math. So I'm going to do 7 plus, well, the square root of 25 is 5, and 2 times 2 is 4. So I'm going to do 7 plus 5 divided by 4. Then for my other solution, I'm going to do 7 minus 5 divided by 4. And I will just find out what each of these equals. 7 plus 5, if I do that math, becomes 12. And 12 divided by 4 makes 3. So my solution for this one is x equals 3. Now for this one, 7 minus 5 is 2. And 2 divided by 4 gives me a fraction, and I end up with x equals 1/2. So my two solutions for this problem are going to be 3 and 1/2, and I just use the quadratic formula. So let's do the next problem over here. Change colors. We're going to do this again. So now this one is not in standard form. It does equal 0, but it's not in the right order. So remember, I've got to put the x after the x squared. So I'm going to rewrite this as x squared minus 4x minus 7. So I just flip-flopped these two. Is equal to 0. So I have that a is 1, b is negative 4, and c is negative 7. So discriminant first. We're going to do b squared minus 4ac. So I have b squared, so I have negative 4 squared minus 4 times a times c. I'm going to type that in. Again, make sure you use parentheses around your negative. And when I do that one, I get that the answer is 44. So I'm going to plug this in under my square root. So I'm going to go back to my formula. I have it written up here. The x equals opposite of b plus or minus that b squared minus 4ac all over 2a. And so the opposite of b for this problem is going to be positive 4 because b is negative 4. So I have x equals 4 plus or minus the square root of, and I already did the b squared minus 4ac, so I know this is a 44, all over 2 times a. So we're going to have to separate. So I'm going to have to do x equals 4 plus the square root of 44 over 2. And I'm going to have to do x equals 4 minus the square root of 44 over 2. And I'm going to leave my problem like this. And here is why I'm going to leave my problem like this. This is a perfectly acceptable way to leave your answer. And it might come up that you have a math problem that they give you multiple choice questions, multiple choice answers, and they leave them unsimplified like this. And the reason they do that is because square root of 44 is not a perfect square. If I go plug this in, I'm going to get decimals. And I realize I can't graph these numbers on a graph, but this unsimplified version of this is completely acceptable. It is equivalent to me going ahead and doing 4 plus the square root of 44 and then dividing by 2 and getting a decimal. I'm going to leave it in this form. So you can either leave it like this first number, this first one right here, the 4 plus or minus the square root of 44 over 2, or you can write it as two separate ones. It doesn't matter. I just know that on last year's end of course, last year's STAR test, there was a question that asked students to solve a quadratic equation, and they used the quadratic formula to do it. And I know that they used the quadratic formula because at the end, their answers looked like this. So they left them in this unsimplified form of the quadratic formula with the square root still as part of the answer. So it's okay to leave it like this. So that's where we're going to stop. So that is the quadratic formula. You'll practice this when you come into class tomorrow, and I will see you then.